This meeting is being recorded.
In Chapter 19, Problem 15, we're asked to predict the major products for each of these reactions shown below. So I've outlined above here the steps involved in a transformation of a ketone to an amine. So that's what we're going to see for parts A and B. And then in part C, we'll see an aldehyde. And then once again, in part D, we'll see a ketone reaction here. So we have these 6 steps outlined. We have first the nucleophilic attack, 3 proton transfers, loss of leaving group in step 5, and then 1 final proton transfer for step 6. So let's take a look at what happens in our part A here. So instead of treating the ketone with a primary amine, we use ammonia as the nucleophile. So this is our nucleophile here. So we would expect to have a similar cyclic structured product result. That's challenging whenever you have to draw a 7-membered ring. And then instead of an R group being bonded to our nitrogen on top of this amine, we're going to see just a proton. 2 of the protons get removed in these proton transfers, but 1 will remain. So this would be our amine product that we predict. In part B here, we're once again going to have a primary amine under these acid catalyzed conditions. So here's our primary amine. So when we draw this predicted product, we will retain that R group. So we're going to draw here our 5-membered ring. We're going to attach to our nitrogen group, and then coming off of that, we have another 5-membered ring. So this would be our predicted product for part B. Now we have part C shown here. And we have, again, acid catalyzed conditions. We'll have removal of a water molecule, but now we have an aldehyde. And this can also react with a primary amine. There's our primary amine, which is tethered or connected to our carbonyl in our aldehyde here. And we're going to see an intermolecular reaction occur under these acid catalyzed conditions. So what we expect for our product would be a cyclic compound. So let's number these carbons here to help us when we draw our product. So we have carbons 1, 2, 3, and 4. And now we would have placement in our ring like so. This would be carbon 1, 2, 3, 4. Let's draw it first, and then we'll number. So 1, 2, 3, 4. So we have what should look like a 5-membered ring here, including the nitrogen. For the last part in this problem, we have a ketone once again, but we're going to see a similar reaction to what we saw in part C, where our primary amine is connected to our electrophilic site. So we're going to once again number our carbons here to help us draw our product. And what we're going to see is, let me renumber them because we have carbon 1 here now because we have a ketone. There we go. So that makes more sense. So when we have this intramolecular reaction, we should see our nitrogen. That will be bonded to carbon 2. We have a methyl group. And we should expect to see something like this. So this would then be carbon 1 here, 2 here, 3, 4 with those 2 methyl substituents, and then carbon 5 up top.